Hello everyone, this is me Mark. So we have here for solving voltages, current and resistance using derivatives. So we can use the connection between current, resistance and voltage using the derivative. So note that Ohm's law states that voltage is directly proportional to current and resistance. So we can have also um, current is inversely proportional to voltage over resistance, or we can have resistance over inversely proportional for a voltage over current. So further with that, so note that when we recall Ohm's law, we have here this triangle for the equation to further understand. So if if we want to find the voltage, so we have the equation voltage equals I times R, or if we find current, we have voltage over resistance, or if we get resistance, uh, we can have a voltage over current. So what if we use this equation to the derivative? So as the current changes as the current changes its or varies its value in time, or we can say that voltage varies at any given time, or also we can have the resistance, which is t represents time. In this figure we have the three um, definition of a derivative, applying the derivative in current, voltage and resistance. So what if we take the derivative of this function with respect to time, just the time, multiplied by resistance? So what if we use the equation for voltage, like another, wherein voltage equals I times R in Ohm's law. So as the voltage changes in time, so we can have the equation of I, the derivative, or dl or dt, which is dl or dt is represents the changes in current times R, or we can simply equate this equation in this particular, wherein this is the resistance times the dl over dt. dl and dt represents the current, so don't get bothered, it's same as this equation. dl over dt represents I. Okay, so let's take examples. So what if we can say that the circuit has the resistance of 5 ohms, and the current flowing through a circuit is described by the function of the current equals 2v2 plus 3t amperes. So note that in current we have the current symbol for current, and for resistance we have ohms, or this kind of symbol. So on voltage we have here the B, or like symbol is B over there. So where time is in seconds, so this equation, um, find the voltage across the circuit at time of 2 seconds. So in this equation, voltage is unknown. So we can use the equation here. That's the VIR, or simply the derivative of voltage times R over times resistance, R times current, or resistance times current, or DL over the derivative of E current. Because in this case, in this given equation, given example, um, only this equation have the like we called it function. You can say that the function. So right now we can use this equation, which is voltage times R on the derivative of dl over dt. So we have this given on the example that we have. So the voltage is unknown, so we can use the derivative of voltage times resistance over times derivative of I. So we can, first step, we can get the derivative of this equation, and so we have here the derivative of this function, 2t squared equals, using power rule, time 2 times 2, then 2 minus 1 equals 4t, plus we can simply copy the derivative of 3t equals 3. Then we can multiply it by this 5 ohms, because resistance, so here times 5, so we can have 20t plus 15. Note that t is represents time, or the changes of current at a given time. So right now we can substitute the t value in this equation, which is the 2 seconds, to get the voltage that run through a circuit. So 15 and the 2 seconds dot. So we have here substitution. We use the BT equals R times DL. We get derivative of the current. So we can have substitute all the equation, substitute all the t value with 2 seconds. So we can have 2 plus 15. So 20 times 2 equals 40 plus 15. Oh, no, sorry, 15. So we can get 55 B in total, 55 volts. That in 2 seconds, the voltage across the circuit is 55 volts. That's how we apply the derivative of a function in calculating the voltages, current, resistance. So we can use other equation if I is unknown or R is unknown, and it also depends on the given on a problem. If R is this kind of equation that we can use the derivative, so we can derivative it, or if voltage is also this kind of equation, we can use the derivative of the function. So that's it for solving voltages, current, um, resistance using derivative. Thank you very much, guys. See you.